So this is another role of the mitochondria that I think we need to pay attention to beyond just producing ATP. It is the mitochondria that decide if the cell is dysfunctional or if there's certain parts of the cell, certain proteins that are dysfunctional. If it senses dysfunctional cells, it signals a process called autophagy. Autophagy is the body's recycling and repair in process of the cells. So the mitochondria, in conjunction with enough melatonin. So this is where artificial light at night and lack of morning sunlight can be a detriment to this process because we don't get appropriate melatonin production. But when the mitochondria sense the damage and when they can use the melatonin as a repair hormone, it signals the process of autophagy. Autophagy then is like the cell waving a little flag saying, ooh, this protein is broken, this protein is broken. And then various proteins and things can fuse together, organelles can fuse together, and they can kind of share their functional parts. They can get rid of their dysfunctional parts. They get sent to something called the lysosome that kind of is like the digestive tract of the cell, like the stomach of the cell. There's a bunch of acid that breaks things down. And so all of a sudden, after the autophagy process, the cell is as good as new. The cell is able to say, okay, we need to repair this, this, and this. The mitochondria send that signal. The cell goes into the autophagy mode. And the end result is a cell that's as good as new because of recycling and repair. The alternative to that is a very energetically expensive thing, which is called ubiquination, which basically is you need to completely rebuild a new cell, right? And so the cell is always trying to repair, always trying to recycle if at all possible, because it's very energetically taxing to the cell to always have to build a new cell with all of its new parts.